Hello again. To continue from the previous video about the electronic control unit, let's see the various types of control units that are popular in vehicles nowadays. First is of course engine control module, next is body control module, transmission control module, ADAS control unit, and this ADAS control unit I have kept it two different varieties because we are concentrating on ADAS. Next is telematic control unit, brake control module, powertrain control module, battery management system. No, this is just for example. I just pasted some photographs so that you all can get an idea how an ECU looks like. But as I said, this is not by any means the exhaustive list of electronic control unit used in automobiles. Now let's see what exactly is comprised in a electronic control unit. What exactly is what electronic control unit is comprised of? First, it is comprised of core microcontroller, next memory SRAM, EEPROM, flash. I think everybody knows what is flash memory. Next, inputs where supply voltage, digital inputs, analog inputs, and next the output facility, actuator drivers, H-bridge drivers for servo motors, logic outputs, and discussing about communication skills comprise of housing, bus transceivers for K-line, CAN, Ethernet, and of course the embedded software. And for the embedded software, bootloader, metadata for ECU and software identification, version management, checksums, functional software routines, configuration data. Now these are all the major or common key elements of ECU. Next is microcontrollers and processing units. Microcontroller and processing unit are the integral part of the electronic control unit. What is microcontroller? A microcontroller, often known as MCU or often abbreviated as MCU, is a small integrated circuit that has input-output peripherals, a CPU, and memory. And because of its real-time operating architecture, it is perfect for jobs like actuator control, sensor reading, and unit-to-unit communication. Okay, understand this sentence very carefully. This has a facility for real-time operating architecture, and that is the reason why microcontroller is used for actuation control or sensor reading. All right. Next comes a digital signal processor. Now, digital signal processor is used in ECUs to process and convert data from variety of sensors into a format that can be analyzed. Okay, so the raw data can come into any format. So that format should be converted into a format that can be analyzed. And digital signal processors are specialized for signal processing activities. The purpose of the digital signal processor is to convert from one format to readable format. Compared to microcontrollers, DSPs are faster and have higher capacity for parallel operation execution. Also, application specific integrated circuits. Now, what is this ASICs? These are specially made chips made for certain functions inside the ECU, such as sophisticated emission control algorithms. Okay, nowadays ECUs are also called SoCs or system on chips. And system on chips have some customized functions and customized algorithms so that they take care of some specific functionalities. For example, let me give you an example. An ECU is working on ADAS. Now on that ECU, a separate functionality which can take care of the body control module also can be integrated. Okay, that is called system on chip. So various systems can be integrated onto one chip, and that is called system on chip. But anyway, that is slightly beyond the scope of this tutorial. I'm just giving you that information for information's sake. Next comes the input and output interfaces. Like every ECU, like every electronic control unit, these ECUs also have input interfaces and also output interfaces. These input interfaces, they get information from variety of engine sensors or any sensor for that matter, including oxygen, pressure, temperature, speed sensors. And if it is ADAS, the sensors, what do they give the input? They give inputs like light, they give inputs like distance, velocity, velocity accuracy, distance accuracy, and also the depth of the object. All these are the various inputs. Okay, the light signals or the radio signals or the sound signals are the inputs. All right, now the output interfaces. These provide the fuel injectors and ignition coils with control signals, and these actuators are driven by analog signals that are converted to digital commands using digital to analog converters. Now let me point out that there is a separate session which I have prepared for actuators, but that particular session is strictly for ADAS actuators. Always remember, ADAS actuators or any actuator is like the hand and leg of the entire embedded system. If sensors are the eyes and ears, hands and legs are the actual execution devices. They actually execute the purpose. Alright, so I have prepared a separate session for ADAS actuators. I am sure that particular session will educate you about all the various aspects of these actuators. Now, further to go into the bill of materials of the electronic component or the exploded view of the component, memory and storage components, they form important subsystems of the ECU. And again, within distinct kinds of memory and storage are needed by the ECU for distinct purposes. First memory is random access memory. RAM. When I'm sure everybody heard about the word RAM. For example, if you bought a laptop, the shopkeeper always says this has this much RAM, this much ROM. So I'm sure everybody is familiar with this acronym called RAM. And when the program is being executed, the processor may need to access the data and variables immediately. Thus, these are stored in this temporary data. And data can only be stored until it is powered by supply voltage. Okay, so this is the actual memory where the processor accesses the data. Next comes the read only memory, ROM. Now in ECUs, ROM are quite uncommon. Okay, they are not actually a standard part of the ECU, but sometimes it may be available. This kind of memories, which can only be programmed once and is never deleted, is included in certain ASICs. And this typically contains a device hardware parameters, including address, reset modes, and connection mode. Okay, now let me point out, even if you are coming from mechanical and automotive background, these are not exactly very important if you want to pursue your career in ADAS. I'm just giving you this basic information because you will be working a lot on the ECUs. And most of the time, as I already said, ECUs are usually generated by tier 1 and tier 2 suppliers. So as a ADAS engineer, you personally will not be working on the ECU. You will be more interested or more concerned about the output of the ECU. Okay, just to continue further, flash memory. Flash is the EEPROM type used to store the microcontroller's real software. So the actual software, the real software is stored in the flash memory. Next comes the data logging and storage. So what is this data logging and storage? I will just read the definition here. The majorities of the ECUs have EEPROM storage for data logging, which is useful for performance monitoring, diagnostics, potential software upgrades. So all these your OBDs, your diagnostics are stored in the data logging and the storage. For instance, if the ECU stores a fault code to the EEPROM, if it detects a problem before it browns out. Alright, and the ECU can read the EEPROM and notify the vehicle system of this error during the subsequent power cycle. So it not only detects the fault, it definitely informs and notifies the vehicle system of this error in the subsequent power cycle. Now let's discuss this sensor data processing and signal conditioning. Again, I'll just breeze through these particular topics because as I said, for a particular ADAS engineer, for somebody who is very thorough about or very keen about career in ADAS, this is too in-depth topic, so I'll just breeze through these topics. First is to guarantee the raw signals are transformed into precise useful information. Signal data processing, sensor data processing within ECU is a crucial essential step. Okay, and how does it happen? First, it happens from analog to digital conversion. Next, signal filtering. Next, calibration and scaling. Next comes the fault detection and diagnostics, and last is data fusion and integration. Okay, I request all of you to pause the video here and go through the definitions very clearly. Okay, in case you are keen about these particular definitions, I request all of you to pause the video and go through these definitions very clearly. All the definitions are very self-explanatory, and it will give you clear-cut idea what each and every term explicitly means. Okay. Now, who are the top manufacturers, ECU manufacturers in the world? I made a list here: Bosch, Continental, ZF, Minda Industries, Varroc Engineering, Sundaram Clayton, Aptiv, Hella, Forvia, Ficosa, Vitesco, Hitachi Automotive, Waifu Group, Mitsubishi Electric, Lin Control, Marelli. Most of these companies have their branches in India. Okay, the only company I never heard of is that Waifu Group. Other than that, all the remaining companies, they have their own manufacturing, not manufacturing setups. They have their own development centers in India. Okay, so this with this I with this brief overview, I end this particular session about the overview about ECU. All right, thank you.